Hey folks, this lesson is a fast one, you guys, and I think you did it in Integrated Math 1. This is an Integrated Math 2 lesson, so this one's called Dilations. Okay, so here we go. Let's get started here. Don't forget all your lessons can be found at Mrmathblog.com. Here's our question: is how does a dilation transform a figure? Okay, so dilations. Here we go. So a dilation is a transformation that can change the size of a polygon but leaves the shape unchanged. It's like a magnifying glass, and it just makes a bigger image. It looks similar. It's not congruent because the sides aren't equal. It's just bigger or smaller. Okay, the new figure is magnified into a bigger or smaller image. Okay, the center of dilation is the fixed point which all other points are transformed by the dilation. Okay, so the scale factor, I'm going to abbreviate it as SF, is the ratio of the lengths of the corresponding sides with the image and the pre-image. Okay, so you need your textbooks in this lesson here and the next one and the rest of this week. This is Monday for us. Determine if all transformations is a dilation. If so, give the scale factor. Okay, so these pics are on page 829. Okay, is this the same shape and the same size? Okay. It looks like it's the same shape. It just looks like it's reflected to me, okay? So is it the same shape and same size? I'm going to say yes, all right? So what's the scale factor? So we just got to find some lengths. I like these horizontal ones up on top, so it's 4 to 4, okay? So here's AD, here's A prime D prime right there. So 4 to 4 reduces to 1 to 1. Think of a fraction. 4 over 4 would reduce to 1 over 1. Okay, because it doesn't have orientation, it's not a dilation. And we'll talk more about that in tomorrow's lesson, okay? All right, so don't worry about that right now. So anyway, determine if the transformation is a dilation, and if so, give the scale factor. Okay, so is this the same shape and the same size? Okay, well, it's not the same size, but it is the same shape, okay? Can you see that? Here's triangle ABC. Here's triangle A prime, B prime, C prime. So what's the scale factor? I find it easier if we list the ordered pairs. You can use distance formula if you want and get this distance right here. If I had a horizontal or a vertical, I would totally do that, because then you can just count the squares when it's horizontal. Okay, we can just, if it was going across right here, we can just count the squares, or if it was going down, we can just count the squares. Or you can use distance formula, or this way is easier if you can just list the ordered pairs and then look at, this is 0, 2, this is 0, 4. B is 1, negative 1, and B prime is 2, negative 2. Okay, so can you see the scale of ABC, triangle ABC to A prime, B prime, C prime is they're all multiples of 2, so 2 to 1. Okay, or 2 over 1. You'll find this is easier to use when we get, we're going to use cross multiply in our next module. How about this one? Is this the same shape and same size? Okay, yes on shape, but it's not the same size, so what's the scale factor? Again, I like to list all the ordered pairs, so 0, 2, 0, 3. Okay, 3, 0, this is 5.5, and let me move that over. That's a 0 right there. Okay, and then 1, negative 2, 1.5, negative 3. Okay, so what's the scale factor? Okay, the scale factor is 3 to 2. It's easiest to see it right here. 3 to 2 right there. Okay, all right, so that's how you find the scale factor. Or here, negative 3 to negative 2, which is 3 to 2 still. So the scale factor, um, when I'm going from the smaller one to the bigger one, is 3 to 2. Okay, all right, so the next one here, you guys. So is this the same shape and the same size? And so what is the scale factor? Okay, no, this is not a dilation, because this triangle, can you see the lengths are the same on this one right here, but the heights are different, and so there is no scale factor, because they're not the same shape or the same size. They're different angle measures. This angle is a little bit smaller than this angle right there. Okay, so they're not the same shape or same size. All right, so let's go ahead and draw triangle ABC and A prime, B prime, C prime. So I'd like you to pick up your pencils and draw those right there. So here's triangle ABC, here's A prime, B prime, C prime right there. Okay, so this is how we're going to find the center and the dilation and the scale factor. Okay, so let's go ahead and draw the lines, you guys, from A to A prime. And we're going to draw the whole lines right there, because they're all going to intersect in the same spot. And from B to B prime right there. Okay, so when we do that, We get that. And then here's the center of dilation right there. We're going to call that point O, and then that's our center of dilation right there, okay? And then to find the scale factor, you can just find the lengths. And so if they give you lengths of AC, then you, sorry, this is AC right here, AC to A prime C prime, or BC to B prime C prime, just the corresponding lengths. Or we can go from the center of dilation to each of those points and the corresponding points. All right, you guys, if you are in our class, that's going to be your homework right there. Take care.